Good morning, CableLabs members. So great that you could join us today for September's edition of our monthly webinar series. I'm Glenn Russell. I'm part of the R&D team here at CableLabs, and I'm going to be your host and your moderator for today's program entitled Virtualizing the Headend, a Snaps Proof of Concept. So let me set the stage for the discussion and conversation we're about to have today. CableLabs, working in cooperation with some very resourceful partner companies, has successfully deployed a virtual CCAP core on OpenStack. And our SNAPS, and SNAP stands for SDN NFV Application Platform Stack, our SNAPS initiative, it focuses on assembling a cloud platform using open source software and industry standard hardware. And what we're going to do today is describe to you some of the use cases that have been implemented and provide you guidance on how you can reproduce the technology in your lab on the way to setting a roadmap for deploying virtualization technology in your networks. In terms of the agenda for the webinar, we've got about 30 minutes of formal content for the presentation, and that's going to include some question and answer segments as well. And at the end of the webinar, I'll recap some recent CableLabs deliverables that I think you'll be interested in, and talking about some upcoming events on our calendar. And a reminder to everyone that you'll see a link at the bottom of the page here. This is our webinar homepage. You can click on this link and go there to access presentations from not only today's webinar, but previous webinars as well. And I should mention that a PDF of all the presentation material that you're going to see today has already been posted in the handouts section of your webinar toolbar, so you can download that immediately. And I should also mention that we are going to record this program. So in about 72 hours or so, you'll get a link from us on how you can access a live stream of the webinar, so you could replay it for yourself, or if one of your colleagues couldn't be with us today, you could forward that link to them. So I think you'll be very pleased with our panel of speakers today. We've got Randy Levensalor, who's the lead architect at CableLabs, and Mark Szczesniak, who's an architect at CASA Systems. And Randy's going to start us off. He's going to provide an overview of some of the virtualization efforts in the SNAPS project at CableLabs. He'll also cover and introduce some of the objectives of the proof of concept work that we're going to talk about later on, and why this is so important for access network technology. And Mark will follow. He'll provide some detailed information on the development project, talk about some of the components of the system, as well as some of the practical learnings that he and the team found from working on this project. And a reminder to all participants on the webinar, if you've got a question for Randy and Mark, you're going to use your GoToWebinar software toolbar, and you'll type that in. We're going to take a couple of breaks along the way, and we do value the interaction. That's really a core component of this webinar series, so please take us up on this offer. So it's time to get started. I'm going to turn the floor over to our first speaker, Randy Levensalor. Randy?
Well, thanks, Glenn, and thanks everyone for taking the time today to join us for this webinar. We're really excited to see kind of where we are at with the evolution of virtualization, and especially in the cable access network. You've been getting a lot of feedback recently, especially since summer conference, where we had this demo and a couple other demos, as well as, just a lot of comments around, good place to be at a good time. And this is something, we've been working on for several years at CableLabs. So we're really, really excited to kind of share where we're at and the next steps. Next slide. So we don't do things just for fun because it's a cool new technology. We really have a set of challenges in the service provider space. We're really looking at exponential growth in data utilization. CapEx, OpEx costs can't continue to go linear as they are today and keep up with demand. We all have a variety of hardware types managed, especially through acquisitions and mergers, where there's just hundreds of different types of devices, each with different firmware update paths and different management software. And we really want to find a way to consolidate all that, to streamline it, and to take advantage of some of these economies of scale that we see coming from the enterprise space and across the NFV and service provider space. For some of this, we can look at sharing hardware by moving to commodity platforms. And with our Snaps platform, we're really pushing how much can we do without hardware acceleration, and also how much can we do with entirely open source software, as well as kind of looking at some of the models we need going forward around DevOps, and really how do you share capacity and grow capacity at a rate to meet up with demand. You can see here that this is our portfolio of what we're doing across CableLabs, and this is really just a sampling of where we're working. We're trying to take advantage of other industry forums for making progress. So we're doing some things with OPNFV, which is the open platform for network function virtualization, focusing on open source. And I'm the vice chair of that end user advisory group. And we're really trying to translate a lot of the needs and pain points that we're seeing with operationalizing NFV and moving that and transitioning that to a variety of open source projects. We also have quite a bit of leadership within the Etsy NFV space itself. And we also work on several other open source projects, including Open Daylight, Open Mano, ONAP. And really, if we go up the stack, we have our Snaps. This is really our foundation, kind of like our tool bench for proving out NFV and virtualization. So you'll see more and more demonstrations and applications coming out of CableLabs that use NFV, and they'll all be built on this platform. And that's really why we've been trying to work to have a very easy environment, so that way we can quickly spin up new projects in the virtualization space and be agile, kind of one of the monikers of moving to virtualization. And on top of this stack, we have Curio spun up a NFV interop lab, and that's actually where the demo with Intel and CASA was built. We've virtualized, our access network for HFC as well as for fiber. We're looking at several business services use cases. SD-WAN is a leading use case there. I won't go too much into our demo we've done in that, but do feel free to follow up if you'd like to learn more about that. Security is another huge area in this space, and we work very closely with the security team to identify potential threats as well as to influence the open source projects to improve their security measures. And of course, the mobile core is another strong use case. Click in a little bit more. This is kind of where we talk about what really is Snaps. We don't talk too much about the hardware here. We're focusing on generic commodity hardware as much as possible. For now, we're focusing on x86 hardware architecture, but we could also use an ARM architecture as well. Our open source components, we have our OpenStack at the core. We do run Docker and Kubernetes right now. We use Docker both to manage our OpenStack instance, which reduces the overhead needed to run OpenStack and makes it much easier to manage the platform, as well as run containers in the VMs on top of OpenStack. KVM is the hypervisor that we're using. We're using a fairly recent version so we can get some additional performance. We have Open vSwitch, and we're using that with DPDK for data plane acceleration. And there are some other tools we'll be looking at. If you're familiar with Fido or VPP, is another alternate to Open vSwitch that we're looking at. We're looking at kind of some other hardware things. We've really started with the access network and Wi-Fi and LTE. And on the top, you see applications. And for us, an application is really anything that you run in the virtualized environment, even if that application is managing your access network, which is a little bit of a new way to think about an application. It's not just something you run on your phone or an enterprise application. These are real service-focused data plane applications. So, I've talked a little bit about, how do we drive feedback and how do we really influence open source? Because at CableLabs, we really want to, multiply the effort that we put in. And that's why it's really good that we have some strong open source communities and relationships. We've actually written an open source library called Snaps OO, which is an object-oriented set of Python libraries, which make it very easy to write tests and manage NFV applications. And that's actually been adopted by OPNFV, so they're actually hosting the project now. And all of their test projects are looking at are in the process of migrating to use our library. So now every time with the OPNFV project, which does integration of OpenStack, OpenDaylight, and works with several vendors, whenever they run a check-in and do their continuous integration testing, they're actually running our tests for us, as well as with their verification and certification process. Whenever anyone goes through that with OPNFV, they're running the tests that we wrote and help guide. And with this, we're really going to push source up to projects like OpenStack, and then vendors take the latest versions of OpenStack, do additional packaging, and provide them to our members, or our members can actually go straight from the OpenStack upstream and manage that yourselves. And then we take the feedback and we apply that feedback to the end user advisory group, or just the open source projects, and to the standards body. So we really do have this, cycle of feedback and continuous improvement. And we've already been able to find some defects and some instability, since we're a little more strict with some of our testing, and we're focusing a lot more on integration testing, not just individual component testing. So this is a little bit about our proof of concept. I'm not going to go too deep. That one orange box there says virtual TCAP core. Mark's going to break that down and go into that into a lot more detail. But really the first part of what we did is we virtualized the access network. So we used the virtual CCAP core VMs from CASA with their RPD, and then Intel provided the servers and the cable modems, and we ran the Snaps software on top, and we basically were able to run the data plane and control plane all in the same cloud. And with this, we were able to do connectivity, all the DHCP requests for the cable modems, for the RPD configuration, were all hosted centrally in the Headend on commodity hardware. We didn't do a lot of performance testing with this yet. That is something we're looking at expanding to with future proof of concepts, but we were able to affirm that it did work with sufficient latency and there was no noticeable impact to the applications we were running. So after that, we layered on an application. This is something where you'll be seeing this common theme. We'll be layering on more and more applications over time. And for this, it was LTE and voice calling. So we actually had some of the packet core managed or running in the Headend and some voice termination there. The INS core itself, so the actual back end of the phone system, was just hosted on the cloud. It was out in New England, so we didn't have to have that. That's something that wasn't latency specific, so we just do that out on the internet. And we had a small cell provided by CASA, and we were able to do call handoffs between the Wi-Fi cable modem and on the small cell, and we did Wi-Fi preferred. And this is, again, was probably one of the most popular demos at Summer Conference. And if you haven't seen it, we do have this running at CableLabs. So do let me know, or let any of us know next time you're in the office, and we can show you. If it's up and running, we do tend to tweak it from time to time and try to add things to it. And I think we'll also have something maybe with a few extra bells and whistles at SCTE as well. So another set of proof of concepts we did with Aerosint and the innovation team, we're looking around, what can you do with the platform, and what are some low latency use cases? And so one was we actually ran a autonomous vehicle simulation and used an actual mobile core on Snaps to do collision detection. And basically, if we had like 10 or 15 milliseconds of round trip time, you were in the car in front of you. If it was down to less than 5 milliseconds of round trip time, so something, in the distance of a Headend or point of presence, you'd be able to actually do that collision detection from the car. And then we also looked at, how can we use this to help the backbone capacity? And for that, we did a CDN application. And then again, this was all on our Snaps platform running on x86 software. And we used a management and orchestration platform from Aerosint that is close to following the FCNFV specification. And we're looking at, how can we continue to follow the FCNFV spec, as well as move forward and provide feedback if there are any gaps. Great. So, one of the questions we get, it's cool, we've kind of proven the technology works, but, is it good enough? We talk a lot about agility and things like that. So we're now starting to look at, taking a step back and say, well, will it meet our customer needs? And for that, we're looking at, latency and throughput, leveraging a lot of work that was done with the low latency DOCSIS project. And then also looking at what are the hardware requirements, density, power, utilization, so kind of power per gigabit. Just kind of why that's on the performance side as well as the cost. So we're saying, can we do this in the same or better density than a traditional CCAP core? So kind of covering a little bit of what we've done today, and then going forward, we're going to continue to evolve our Snaps platform and update to the current version of OpenStack, improve some of the networking capabilities. Mark will highlight some of the challenges we had with that later on, and we're looking at addressing that in the platform, as well as open sourcing the installer. So any member can download it today. We can provide a link for that if you reach out, but we're moving actually to post it publicly so that anyone can use it without having to go through CableLabs. And also continuing our vendor collaboration both in CableLabs and with Curio to do additional integration, look at what happens if we change out different components and have multi-vendor solutions, as well as to look a little more at the performance capabilities. Thank you. Back to you, Glenn.
Okay, thanks so much, Randy. Great start to the webinar and a great summary at the end there of preparing to virtualize DOCSIS and some of the next steps underway. And audience, as I mentioned earlier, how you ask questions of Randy and Mark, you type the questions in and we'll field them along the way. So let's get started here, Randy. So if you're if I'm an app developer, how do I get started?
Yeah, so really, if you want to, start working with our platform, if you reach out, we have our installer that'll install the OS and the VMs, and then we also have some shared labs that we can provide access to.
Okay, great. And another question on contribution here. How do you contribute to the Snaps OpenStack platform development?
Yeah, so this is something we're really excited about. So we're working to release all of these as open source, so they'll be posted on GitHub under an Apache 2.0 license. And once we have everything out there, anyone will be able to submit a patch to either add features or fix a bug and really kind of make this a truly collaborative project going forward.
Okay, and how is security being addressed?
So, there's a lot of security work that we're doing right now in the NFV space is through the NFV Standard Security Working Group, where we actually have the chair works for CableLabs, and we're looking at providing contributions and ways to leverage our PKI infrastructure that we're using today on the cable modems. And then within the stack, we're actually starting to look at, can we do some additional penetration testing and other more hands-on security auditing.
All right, questions keep coming in, Randy, so we'll keep plugging away here. So what do you have in the way of regression tests as you upgrade, redeploy? You talk a little bit more about the maintenance upgrades and how that whole cycle works.
Certainly, yeah. So within our Snaps.0 framework, we have about 300 or 400 tests that we're running today. And we run those periodically and definitely run it after every single install and upgrade. And those do everything from some very small point testing of certain APIs to deploying multi-VM deployments with multiple network connections and somewhat complicated on the networking side. And we really drive a lot of these test cases out of areas where we found issues in the past. So if we encounter a problem, we'll actually add that to our testing and part of our continuous integration testing and build.
Okay, thanks. And here's a technical one as well. I've been told that containers are faster than VMs. Why are you still using virtual machines?
Yeah, that's something that we continue to hear quite a bit. So containers definitely have a great trend going forward. There are still a few challenges with containers around security in multi-tenant environments, though I believe they'll be resolved in the next couple of years, as well as the ecosystem of DNFs. Those are much richer in the VM space. So we do support containers, and we are able to get comparable performance with VMs, if not better sometimes, because they're using the same virtual switching. We have a little better isolation, and we're able to actually dedicate resources. So for a lot of the NFV applications, we don't oversubscribe the server, and we can pin specific CPUs, specific memory, and specific IO resources to the VM. So it really does get, for many use cases, comparable performance to bare metal.
And I'll squeeze one more in, Randy. So what OpenStack services do we support? Nova, Cinder, Neutron, anything else?
Yeah, so we have all the core components: Nova, Neutron, Cinder, Keystone, and Glance. We also have Heat support, and we're looking at Magnum support, which gives us the containers on top of OpenStack. And we're looking at adding in our next release, Tacker support, which will give us Tosca-based orchestration, and that will be continuing to kind of expand with some of the functionality that we need there. We aren't doing things like firewalls as service yet, because we're looking at actually spinning up a variety of firewall applications that are a little more robust and performant than the native OpenStack version.
Okay, let's pause with the questions. Hat tip to the audience. Really great questions, guys. So appreciate that. And we're going to move on to the next speaker, and that's Mark Szczesniak, architect at CASA Systems. And I'll turn the floor over to Mark. And at the end of his presentation, we'll take some questions there as well. So over to you, Mark.
So I'm going to start talking first with our fixed mobile convergence proof of concept that we did. Then I'll talk about kind of the differences between NFV, generic virtualization, and dedicated hardware. And then I will go into some of the key learnings with our working with Curio. So we start with our fixed access solutions. This is our VC cap. The idea here is you have the hardware on the left side, you have the cable modem, which has always been there. The remote PHY is what we're breaking out of our current CCAP architecture, because that's the physical, which needs to remain. And then everything else we virtualize. So we've split our software into two pieces, our control plane and our data plane, basically because they're going to scale differently. The control plane will probably just have a couple of VMs running so you can get some HA. On the data plane, we see the scale going up as your throughput goes up. So as your CCAP gets larger and larger, you just add in more and more data planes. We also plan in the future to break out the video data plane from the DOCSIS data plane because, again, there the scale will be different. So this next talks about our mobile side and their VMs. Basically, mobile, we've broken into two different pieces. You basically have the access side and the core side for the VMs. The access side is really takes into account the security and talking with either the AP or the small cell. So the homey node B gateway will talk with the small cell. The virtual EPDG will talk with the access point for Wi-Fi. And both will send the traffic right through to the EPC core, which is your vault packet core. And that's where the S gateway, the P gateway, and the MME reside. And that's really where your IP address is given out, and therefore it can go back and forth between the small cell and Wi-Fi as needed. And that's how we do the handoffs. And when we showed in the demo was having a cell phone make a call, then we would bring down the access point and show that it would cut over to using LTE, and the phone call would stay up. And again, both eventually go back out to the internet, which is really where all of the, it's where you validate the users coming in. So the next slide really shows how we put it all together. And we just show kind of the different pieces. On the left side, You have really all the hardware pieces from your cell phones. We can have cameras, whatever's hooking up via the small cells or the cable modem, the access points. Our remote PHY goes over there. Then in the middle, we have really what's the OpenStack platform. You have your CUP servers with your different apps running on top of them. And again, all from the virtual CCAP to our different mobile apps, they were all running on the same set of servers. And then they go out to the internet for AAA and HSS for doing your validation. So just to go into some details about what we see as some differences and some things to think about when you're deciding to move to NFV. First, some of the key resources. In generic virtualization, the idea is a lot of times you're looking at things, you're looking at CPU, memory, and disk space for a lot of generic applications. And networking is kind of an afterthought. It's not something that you tend to need a lot of, and it's not looked at very highly. But with networking functions, the actual NIC card and maybe you need hardware acceleration become more of a key resource along with the CPU. Memory and disk space are less needed. I mean, you still need your memory, you still need some disk space, but you don't need gobs of it because you don't tend to have huge databases or anything like that. But having a bigger NIC can be very important. Instead of using a one gigabit throughput NIC, you may want a 10 or even 100 gigabit NIC so you can get a lot more through the servers that you're using. And so for NFV and dedicated hardware, those tend to become more important resources. If you start to look at scaling, well, virtualization NFV, really they scale with the number of compute servers, just like dedicated hardware would scale with that hardware instance of whatever you're buying. So those kind of look about the same. It just becomes, whether it's dedicated hardware that you're scaling or your compute servers. Performance becomes a little bit different as well, because with generic virtualization, it's really about using the CPU and putting as many apps into the CPU as you need it, or as many CPUs for the app if you want to scale the app up. With NFV or with your dedicated hardware for networking functions, you still have the CPU that you need to scale up as you need to scale, but because you want the throughput to scale as well, you need to start looking at your NICs, and at times when you're doing things like crypto, that's where the hardware acceleration comes in, because currently the CPUs, yes, they can do crypto, but the amount of CPUs you need tends to go up by 3 to 4 times when you add crypto into the processing of packets. And therefore, hardware acceleration can actually cut the number of servers you need by 1/3 or 1/4, maybe a little more. Depends on the type of crypto you're doing. So these are some of the things we learned in our working with Curio, and we really enjoyed working with the personnel. They were very dedicated, very supportive. We had daily progress meetings to see how the different demos or how the POC was going, trying to resolve issues and stuff like that. Things went pretty well. The lab setup, we had very good documentation about the lab ahead of time. We got root access to everything so we could easily debug things. And then out of it, we had a lot of customer interest. We even are going into a lab trial with a customer now. So, those turned out to be some of the good things we got out of working with Curio. But we also had some challenges. So the first challenge we had was just the installer, just getting our stuff up and running the way we had set it up ourselves. So the first installer didn't work well with L2 network, so we had to move on to a second installer. The second installer, it was a little bit harder for us to deal with because it wasn't open source yet, so we couldn't get a copy of it. But eventually, I believe that's happening now, so that hopefully won't be a challenge going forward. The other piece where we had a lot of challenges was on the networking side. OpenStack is basically more set up for layer 3 networks than layer 2, and some of the stuff we do was all layer 2, especially talking with our remote PHY right now, we were using pure layer 2. So that took a little bit of work. And then there was some extra things where OpenStack expects to do DHCP, and so it actually was blocking, OBS was blocking a lot of the DHCP packets that we needed to go to give the cable modem and remote PHY their IP addresses. And so we had to hack into OBS to prevent that, prevent them from blocking the packets such that we could do our DHCP relay and stuff that we needed to do. Another issue was the MTU size. The MTU size was 1500, within the core, but as we had the DOCSIS headers, it was bigger, so we had to shrink down the size of the packets that we could handle, such that we could actually get them through with the DOCSIS header. There's also some port security issues where they were looking at the IP and MAC address, and because we use logical interfaces to talk out to the remote PHY and to the cable modems with IP addresses that OpenStack didn't know about, it was blocking those as well. So those, we had to relax some of the security that OpenStack put in, just so we could get those packets through. And I think that's it. Thank you.
Excellent, Mark. Great overview of the development effort and what you guys demoed at our summer conference this year. Let's dig right into some of the questions here. First one is about scalability. So does scaling really proceed linearly? Excuse me. Do you need SRIOV hardware, and do you have to pin NICs to certain NFV virtual machines?
So yes, what we found so far is it proceeds linearly. We haven't done huge scale tests where we've scaled up really far yet, but with our beginnings, it looks like it proceeds linearly. We do use SROV, and that really comes down to what kind of throughput do you want? I mean, yes, our application will work without SROV, but the throughput just isn't quite there because most of the V-switches, you know, the V-switches themselves, you can get it, tend to be slow to begin with. I know they're enhancing OVS with DPDK, and we internally were using Wind River's Titanium server, both which had an enhanced V-switch. And with those, you don't need the SROV, but then you run into kind of scaling issues in that the V-switch now needs a lot of cores. So it's, do you want to put the cores towards the V-switch, or do you want to use SROV? And either can be an option. It just goes to how high do you want to scale. And do we pin NICs to certain NFVs? Well, once you use SROV, you can actually give virtual functions to each of your VMs, so that really isn't an issue.
Okay, great answer. And next question is, well, it sounds like you had a good experience with working on this project with Curio, CableLabs, some of the other partner companies. Can you elaborate a little bit more as to why that worked out so well?
So at the summer event, you know, the POC got a lot of attention, which is, you know, something as a company we're looking for. We want to talk with customers. We want to, you know, get them in so we can present our solution. So we thought that was great. You know, it was a good conversation starter, you know, and with the different operators, and we got a credible lab trial with a notable North American provider out of it. So, you know, that was a lead generator. You know, those are the things we're looking for as a vendor. So that this helped. We also are looking forward because we're going to have it feature in other events going forward. It wasn't just Summer CableLabs. We're going to take the same thing to some of the other events. I believe we're going to be in SCTE and maybe some other ones going forward. So, you know, beyond the demo, you know, we're working with Curio, CableLabs, and Intel to continue this momentum. We're going to have joint marketing and other things that came out of it. So, you know, we look at it as a win for us.
And we'll open up the questions to both of you guys right now. We got a few that we weren't able to cover earlier. So this next one is, where's the most logical place to deploy snaps? Is it in the head end, the hub, both? Any thoughts there? Do you want to, I'll let you start, Randy.
Yeah, so we're really, you know, looking at what can we do with it in the head end or the hub, kind of somewhere that's closer to the customer site. You can definitely also do some offloading with doing more of a regional data center. But a lot of what we're doing is trying to find the low latency edge use cases.
Anything to add at all to that, Mark? Any perspective from your side on?
So for us, it kind of it will depend on what you're trying to do. I mean, we make our apps so that they can run anywhere, but certain apps tend to run out closer to the access. When you're talking about the VC cap, you know, there's timing considerations. So pulling them all the way back into your data center may not work so well. Depends how far away the data center is from the cable modems. But that's just a restriction on, you know, DOCSIS and you know, how close the cable modem needs to be to the head end to begin with, or to the CMTS to begin with. So those restrictions are still there. So, you know, it's up to where you want to put it, and can you get it all the way back to your data center, or is that too far away?
Okay, got it. And there's a question here, and I think this might be for you, Randy. You mentioned Tosca. What about Yang?
Yeah, so we're seeing Tosca as kind of something that's come more from the IT space. So we're using Tosca as part of the CNFD specification for defining the service. But we actually do have Yang, or we see Yang having a strong role in defining the network layout and topology. Since that, you know, something that's very well established in that area. And there's even some additional work going on in that CNFD to extend Yang to do some more of the NFV use cases.
Okay, great, thank you. And let me just close with one question here, and it's about, are there additional use cases for virtualization that you guys can see that either coming out of your proof of concept development or anything beyond what you did here that you think the audience should be looking for, or that you guys may go, directions that you may go next?
Yeah,
so I can start there.
Go ahead, Mark.
Okay, so thanks. So the idea is at CASA, we plan to virtualize all of our products. So, you know, what we have shown in the POC is really our mobile products and our virtual CCAP. We also have PON and B&G products that we plan on virtualizing as much as we can, and our Wi-Fi products we plan to virtualize. So, you know, we'll take it through all of our products, and as we add more products, they'll all be virtualized.
Yeah, and on top of what Mark said, you know, really anything that's being done in an ASIC today, we want to virtualize and see how well it works and what the cost metric gives to see if it's ready to go into the field or if it needs to wait. There's quite a few interesting use cases around AI. If you're at summer conference, you might have heard some of those, as well as looking at, you know, doing more complex offloading for your phone, and really just, you know, there's going to open up a whole new world of applications that we can virtualize. You know, some things will actually be moved further from the customer site to more of a central location. And then there'll be other things that'll make sense to move onto the customer premise or on the edge. So we're really quite excited. You know, video is something we're working on. SD-WAN and orchestration, we're actually looking at, you know, combining more and more of the demos we've done and putting them into, you know, kind of more of a real world end-to-end demo. And to be honest, we kind of have this huge backlog of vendors we're working with. And I'd encourage everyone here, if you do have any vendors that you're working with in this space, to encourage them to work with CableLabs and Curio, so we can actually, you know, do some common validation and hopefully save you a lot of time on proof of concepts and understanding the requirements ahead of deployment on your side.
So some bold and ambitious visions from both Mark and Randy there on what's next for virtualization. So why don't we end there, and let's thank Randy and Mark for two excellent presentations today, and even more so, great job fielding so many great audience questions, really. So thanks to the audience and everybody who participated and submitted questions.